You know that feeling? You open Netflix, and bam, there it is. A suggestion that just feels perfect.
Hmm.
Or you finish a YouTube video, and the next one up, something you actually want to watch. It's kind of spooky how personal it feels.
Yeah, it really does sometimes. Like, how did it know?
Exactly, but it's not mind reading, is it?
No, not at all.
Yeah.
It's all about reading data, just vast amounts of data.
And that's precisely what we're getting into today.
Yeah.
This deep dive, it's all about decoding those recommendation algorithms, on Netflix, on YouTube.
Uh-huh.
We're looking at it through this data lens, how these systems grab, organize, and then, analyze huge piles of information to basically guess what you'll like next.
Right, and we've dug through quite a bit of material on this. Research papers, platform explanations, that kind of thing. Our mission here is really to pull out the key takeaways.
Yeah, give you the inside scoop.
Basically, yeah. How these systems actually work, how they use your information to figure out your tastes, and importantly, why that matters. It's kind of a shortcut to getting informed on this stuff that shapes so much of what we see online.
Okay, let's dive right in then. The absolute bedrock of all this is the data collection part. Just how much info are we talking about? What kind of details are Netflix and YouTube logging?
Oh, it's genuinely enormous. And the detail is pretty fascinating. Take Netflix. They log pretty much every single thing you do on the platform.
Like what specifically?
Well, the obvious stuff first.
Yeah.
What you watch, how long you watch it for. But also, like, when you hit pause, or if you rewind a bit to rewatch a scene.
Oh, wow. So even those little hesitations, they count.
Absolutely. They're all signals you see. And beyond just watching, they track every rating you give, thumbs up, thumbs down.
Right.
Anything you add to your watch list.
Yeah.
Every single search term you type in, that's
Yeah.
recorded too. And even just browsing counts.
Mm.
How long your mouse hovers over a title before you scroll past, whether you click on it,
Mm.
and then, crucially, if clicking actually leads to watching it or if you just back out.
So even just thinking about watching something leaves a trace?
Pretty much, yeah. And the scale, it's mind-boggling. One source, pulling from Netflix's own tech blogs, mentions billions of user ratings logged. Billions. With millions more added daily.
Wow.
And millions of viewing events every day, too. Duration, the time of day you watch, even the device you're using, like your phone versus your TV.
And it's not just about us, our behavior, right?
Yeah.
They also gather data on the content itself.
Oh, absolutely crucial. Every movie, every show has this rich layer of metadata attached. Genre, obviously, but also cast, directors, the year it came out, average ratings.
Mm.
They even pull in outside data, like how well a movie did at the box office or what critics thought. It all helps build a profile of the content. Plus, contextual stuff like your general location or the time.
Okay, that's a lot for Netflix. What about YouTube? Is it a similar picture?
Very similar in principle, yeah. But the scale might be even wilder. One source quotes a YouTube engineer saying their system juggles over 80 billion pieces of information.
80 billion.
Yeah, pieces of information they call signals. That's across all users, all videos. It's basically everything they track.
What are the key signals for YouTube then?
Well, clicks are one, obviously what you choose to watch. But they put a huge emphasis on how long you watch. That's the famous watch time metric.
Right.
Your likes, dislikes, any shares, and also feedback from those little surveys they pop up sometimes. Did you enjoy this video? That kind of thing.
I do remember hearing about that shift to watch time being a really big deal for YouTube. Why was that so important?
Yeah, that was around 2012, I think. They basically realized that just counting clicks wasn't cutting it. It wasn't a great measure of whether people were actually satisfied.
Because of clickbait.
Exactly. People would click on some outrageous title but then leave after 10 seconds because the video was rubbish. Watch time, though, that turned out to be a much better indicator of satisfaction.
Makes sense. If you stick around, you probably like it.
Right. So they tweaked their algorithms to prioritize recommendations that led to more total watch time across the platform.
Yeah.
They saw it as a better way to measure if they were actually giving people value, keeping them engaged, rather than just chasing clicks. It was a pretty fundamental change in philosophy.
Okay, so both platforms are just constantly hoovering up incredibly detailed data. Our actions, the content's details, the context, this huge pool of data is the essential starting point, the raw material.
Precisely.
But how do they take this messy pile of clicks and pauses and ratings and structure it so a computer can actually make sense of it all?
Right. That's the data representation step.
Yeah.
You need to get this raw stuff into a format algorithms can actually work with mathematically. And a really fundamental concept here, especially for systems like Netflix used early on, is the user item matrix.
Matrix. You mean like a big grid
Yeah,
table?
exactly that. Picture a massive table. Down the side, you've got rows, one for every user. Across the top, you've got columns, one for every single movie or video. And in each cell, where a user row meets an item column, you put a value. It could be the rating that user gave that item, like 1 to 5 stars, or it could be simpler, just a 1 if they watched it and 0 if they didn't.
And I bet most of that grid is empty, right? I mean, I haven't watched even a fraction of what's on Netflix.
Exactly. That's a key point. The matrix is incredibly sparse. Most cells are empty because most users haven't interacted with most items. But even so, this structure is super useful
How so?
because each number, each filled cell, captures a specific interaction, a piece of data about taste. And the algorithm's main job, looking at this matrix, is essentially to try and fill in the blanks.
To predict what I would rate something I haven't seen.
Precisely, to predict your preference or rating for all those empty cells, corresponding to things you haven't encountered yet.
This sounds a lot like what that famous Netflix prize competition was all about.
It was exactly that. That $1 million prize was for any team that could significantly improve Netflix's ability to predict those missing ratings in their huge user movie matrix.
And the winners use something called matrix factorization. Sounds technical.
It is a bit, but the core idea is actually quite intuitive. Instead of just looking at that sparse grid of who watched what, matrix factorization tries to break it down. It discovers hidden patterns or dimensions.
Hidden patterns, like what?
Think of them as latent factors,
Mm.
things that aren't explicitly there, like genre labels, but that the math can uncover. Maybe it's how much a user generally likes fast-paced action versus slow-burn drama, or how much a certain movie appeals to people who also like sci-fi.
Ah, okay. So it's finding these underlying tastes.
Exactly.
Mm-hmm.
By finding these hidden factors, even with all the missing data, the algorithms could make much better predictions, like distilling complex preferences down into a few core components. It was a big leap in accuracy.
So it finds connections without needing explicit labels. Interesting. But they don't only use that matrix, right? What about all that metadata?
Right, that's the other key part of representation, using the features about the content itself.
The genre, actors, director we mentioned earlier.
Yes. All that info genre, cast, keywords, maybe how new it is, its category on YouTube. This helps the system understand how items are similar to each other, separate from user behavior.
Like, this video is about cooking. That one is also about cooking.
Exactly. Or this movie stars actor X, and you liked another movie with actor X. That similarity is based purely on the content attributes.
And that leads into what's called content-based filtering, doesn't it? Recommending stuff because it's similar in content to what you already liked.
Precisely. If you watch a lot of historical documentaries, a content-based system will suggest, well, more historical documentaries or maybe biographies, things with shared content features.
Okay, got it. So representation is about structuring all that raw data interactions, metadata into formats like matrices or lists of features, turning it all into numbers and structures the algorithms can actually crunch.
Yep, making it machine readable.
Which brings us to the next big step, the analysis. How do the computers actually use the structured data to generate those personalized recommendations? This is where the algorithm will come in, right?
This is where the real prediction happens. And a foundational technique, still super important, is called collaborative filtering.
Collaborative filtering.
Yeah.
That's the people like you also liked this idea.
That's the heart of it, yeah. The system looks for other users whose tastes, their viewing history, their ratings seem similar to yours.
Okay.
Then if those similar users really like something that you haven't seen yet, the algorithm thinks, hey, this might be a good recommendation for you. One source describes it simply as recommending things on the basis of the likes and dislikes of similar users.
So if you and I both love the same obscure sci-fi shows, and you recently watched and rated a new fantasy series highly, the system might flag that series for me.
Exactly. That's user-based collaborative filtering. YouTube has a neat example. If people who watch the specific tennis match highlights you watch also tend to watch a lot of jazz music videos,
Okay.
the system might actually recommend jazz videos to you. Even though it seems unrelated, it finds those surprising connections in collective behavior. The classic people who liked X also like Y pattern.
Interesting.
There's also item-based collaborative filtering. That looks more at the items themselves. If lots of people who watch movie A also watched movie B soon after, then it might recommend movie B to someone who just finished movie A.
Makes sense. And I guess the more data these systems have, more users, more interactions, the better these collaborative methods get.
Absolutely. The power comes from the sheer volume of collective behavior. More data means clearer patterns. And the impact is massive. Netflix estimates something like 75% of what people end up watching comes from their recommendations.
75%. Wow.
And YouTube's figure is similar, around 70% of total watch time driven by recommendations.
That's huge. It really shows how much these algorithms guide our viewing habit.
Definitely. And it's not just about blockbusters. It helps niche content find its audience too, connecting creators with viewers who'd likely be interested, but might never find it otherwise.
It's like a distribution engine. But collaborative filtering isn't the whole story now, is it? Modern systems use more advanced stuff.
Well, yeah. While collaborative filtering is still a core concept, today's systems heavily rely on much more complex machine learning models, ML.
Going beyond just direct similarities.
Much further, these ML models can find incredibly subtle, complex patterns in the data that simple similarity measures would miss. They use all sorts of sophisticated techniques. Netflix talks about using a whole toolbox, things like linear regression, gradient-boosted decision trees, deep learning, neural networks.
Okay, lots of buzzwords there.
Yeah. Basically, they often combine different models. Maybe one model is good at generating a broad set of potential candidates, and another, more complex model is then used to rank those candidates very precisely for you.
And YouTube is big on ML too, right? Using deep learning.
Very much so. They leverage Google's AI research using deep neural networks. Their system often works in stages too. Imagine one neural network quickly scanning literally millions of videos to pick out maybe a few hundred potentially relevant ones for you.
Just a first pass.
Right. Then another, more computationally intensive network takes that smaller list and does a really careful ranking. It predicts the probability that you'll actually watch, like, share, or spend time on each of those candidates.
And these models are crunching all those signals we talked about earlier. Watch time, likes, dislikes, location, device.
Everything. Your recent history, demographics if available, context like time of day, are you on mobile or TV that might influence whether it suggests shorter or longer videos? It all feeds into these complex prediction engines.
And the ultimate goal of all this number crunching
Is to predict, with ever-increasing accuracy, what you, specifically, are most likely to want to watch or engage with next.
So it's this whole pipeline. Collect tons of data, organize it neatly into structures like matrices and features, then unleash these powerful algorithms, collaborative filtering ideas combined with heavy-duty machine learning to analyze it all and make those predictions.
That's the essence of it.
And the result is that personalized row of suggestions that feels like it just knows you. It's really quite something when you think about the scale required. No human could do that.
No way. It's computation, driven by data, enabling something that feels intuitive, but is actually incredibly complex analysis, turning your past behavior into predictions about your future tastes.
It really is data in action. Okay, so we've seen how they do it, but what are the effects? These systems are clearly powerful, influencing what billions of people watch. Let's talk impacts.
Right, and it's definitely a double-edged sword. There are clear benefits, but also some significant concerns.
Let's start with the good. We've touched on this already.
Yeah, the sheer influence is staggering, directing 70–75% of viewing time. That's massive. For users, it means discovering content they might genuinely love but would never stumble upon otherwise.
Like a personalized librarian or music curator.
Exactly. It surfaces relevant stuff from a catalog of millions. And for creators, especially those making niche content, it's a lifeline. The algorithm can pair their work with the specific audience that's looking for it, an audience they could never reach on their own.
So discovery, connection, finding audiences, those are big positives. What about the downsides? I feel like we always hear about filter bubbles.
That's the main concern, yes. Filter bubbles or echo chambers. The idea is that because the algorithm is designed to show you more of what it thinks you already like, it can inadvertently narrow your exposure over time. You get stuck in a loop, seeing only things that confirm your existing tastes or viewpoints.
So it stops you from discovering things outside your usual zone.
Potentially, yes. One source we looked at by Konstantin Bauman points out that traditional systems can lead to these situations in which users are only familiar with a limited subset of items and never gain exposure to items away from those subsets.
Like a music app that only ever plays blues because you liked a few blues tracks and never suggests classical, even if you might enjoy it.
It's exactly that kind of thing. Recommendations can start to feel repetitive, maybe even isolating. Less about genuine discovery, more about reinforcement.
And on platforms like YouTube, this can lead down some weird paths, right? The rabbit hole effect?
Yes, that's a specific concern with YouTube. If you start watching certain types of content, maybe, say, conspiracy theories or borderline misinformation, the algorithm, optimized for engagement might start suggesting more and more extreme or fringe content in that same vein.
Because it just sees you watching similar stuff, so it serves up more.
Pretty much, it's trying to predict what you'll click next based on patterns, and sometimes those patterns lead towards problematic content.
How are the platforms responding to this? Are they aware of these issues?
Oh, definitely. YouTube in particular talks a lot now about responsible recommendations. They state their goal isn't just engagement anymore, but also minimizing the spread of harmful misinformation and limiting recommendations of what they call borderline content.
Borderline content, what's that?
Content that doesn't quite violate their policies but might still be, misleading, low quality, or potentially harmful. Think sensationalist stuff or dubious health claims.
So they're trying to actively not recommend that stuff, even if it gets clicks?
That's the stated aim. They reported making algorithmic changes that led to a significant drop, they claim over 70% in watch time for this borderline content coming directly from recommendations. Their target is to keep it under 0.5% of overall views from recommendations in the U.S.
So they are actively tweaking the system for safety and quality, not just pure engagement metrics.
It seems so.
Yeah.
It highlights this tension between maximizing watch time and ensuring the recommendations aren't causing harm or trapping people in unhealthy echo chambers. It connects to broader societal impacts too, right? If your news feed or video suggestions are constantly filtered, it affects how you perceive the world.
Absolutely. And there are other ethical dimensions too, aren't there? Like bias.
Yes, that's a huge area. Algorithmic bias. If the data used to train these systems reflects existing societal biases, maybe certain demographics or types of content are underrepresented in the data,
Uh-huh.
then the algorithm might learn and even amplify those biases. It might unintentionally recommend content less fairly across different groups or creators. Data privacy is another big one. Just how much do these platforms know about us?
Right.
These are really complex challenges. Fairness, bias, privacy, and engineers and researchers are actively working on them, though there are no easy answers. Definitely topics for future exploration.
Okay, so let's try and pull this all together. We've seen that these recommendation algorithms are a powerful example of data in action.
Totally.
It starts with collecting just massive amounts of data, your clicks, your watch time, ratings, searches, plus info about the content itself.
Yep, the raw material.
Then that data gets represented, structured into things like user item matrices and feature lists so computers can work with it.
Turning interactions into structure.
And finally, it's analyzed using algorithms from collaborative filtering principles to sophisticated machine learning models, all to predict what you, personally, might want to see next.
Analyzing the data to generate those predictions. That's the core loop.
It's basically transforming raw data about your past behavior into new knowledge, new insights about your preferences, and using that to shape your future experience.
It really is data crunching on an immense scale. Not magic, just very clever computation. And it enables these incredibly personalized experiences we now almost take for granted.
So hopefully when you next see those suggestions pop up on your screen, you'll have a much better sense of the complex data journey behind them.
A little peek behind the curtain.
Exactly. And before we wrap up this deep dive, here's maybe one final thought for you to chew on, building on that whole impact discussion. We know these recommendations drive the majority of viewing. We know they can recreate filter bubbles or reflect biases. So given how much they shape our digital environment and potentially our perspectives, how much control should we, as users, actually have over the data profile that fuels our recommendations?
Interesting question.
What's the right balance of responsibility between the platforms designing these incredibly influential systems and us, the individuals, navigating the results?
Yeah, that's a really important question to think about. Where does that responsibility lie? Definitely something to mull over next time Netflix suggests your next binge watch.